In this next video, we are going to look at a probability using discrete data. The situation is I want to take a look at my customers' buying habits. And I took a random sample of 100 customers and determined how many items they purchased on their recent visit. So you'll see how the 100 comes into play in a second. Out of those 100, 18 customers did not purchase any items at all. 39 of the 100 purchased one item. 28 customers purchased two items on their last visit. 12 purchased three, and then three customers purchased a total of four items. That was a good day. I'm going to use the auto sum function here to tally this up, which uses the sum function, but it's a nice shortcut. And there is our 100. So in column A, we have the number of items purchased. In column B, we have the count or the frequency. Well, I'm sure that almost everyone could do the math in their head. I'm going to continue to build this table so that if we didn't have exactly 100, or perhaps one of the customer slips, we couldn't tell how many items they purchased or was lost, we could still figure it out very easily. So if I take this formula where I have 18 and divide it by the 100, that will give me the percentage, which we know will be in a decimal format of 0.18. But here, I'm going to do an added feature whereby I'm going to put dollar signs in front of the B and the 8 with the F4 function button, or you could just manually type them in, so that when I copy this formula down, it will always address the cell B8 for the total count or frequency. This is called absolute cell addressing, and we will revisit this concept and capability in Excel more often. So now, to reiterate that point, I will drag that formula down by 1, and you can see the B3 changed to B4 for the row for one item purchased, but still divided by B8. And of course, I can continue to drag that down, and it will calculate the remaining decimal probabilities or percentages for the rest of the rows. Now, as a good check, I can auto sum that column up, and it should equal 1, which it does. And that just confirms that I didn't make any mistakes along the way. Now, that's part of the story. The next part of the story is to calculate an expected value, which I'm going to shorten to EV for a moment. And that I take by multiplying column A times column C. Now, the values in column D don't have much meaning by themselves. So basically, I can just say equals column A, asterisk for multiplication, column C, and that will give me an intermediary number, which I can copy down. Again, maybe I'll copy it down by 1, and note that A4, which is 1, times C4, which is 0.39, is indeed 0.39. And again, the math is easy enough here for you to do a quick check to see that the math is correct. Now, at this point, where I've got all the values in the column as intermediary values, I will do another sum here, which is going to sum up the intermediary values. But in this case, I'm going to bold that, and that value 1.43 becomes an expected value. That is, on average, I expect the customer to purchase just under 1.5 items per visit. And by digging deeper, perhaps to see what those customers who purchased 2, 3, or 4 items might have purchased, I might be able to move that expected value, often called a weighted average number, higher, which would increase my business, hopefully. So I've done my calculations. Now I can use some of the values in the table to calculate various numbers, just as we did in the previous video. So here, my first question is, what is the probability that if I randomly select a customer and look at their last sales receipt, that they purchase exactly 2 items? Well, I can go right up to the cell C5, and that would give me 0.28. Here, maybe I want to change that to a percentage, and maybe 1 decimal place would be fine, just to show that we can do decimals. So the probability that a customer purchases exactly 2 items is 28%. Then here, the probability of at least 1 item we could get, in terms of our second question, by adding up the 4 values from rows 4, 5, 6, and 7 for 1, 2, 3, and 4 items purchased, or we could utilize our complementary probability of 1 minus the probability that they didn't purchase any items. And again, I could reformat that to be a percentage with 1 decimal. So the probability that they purchased at least 1 items is 82%, which is good to know. Although I'd still like to know why the 18% that didn't purchase any items didn't purchase anything. I will put those formulas in the cell to the right as I've been doing. And even though this is a very simple formula, I should be consistent and do that with the first question. So now I have another question, which is, what is the probability that the customer sales slip selected at random purchased less than 2 items? With the less thans and the more thans, you have to be a little bit careful in that you want to make sure that the answer that you provide matches the question. Less than 2 means not 2, but 2, 1, or 0. So I'd simply add up the 2 probabilities for probability of nothing purchased or 1 item purchased. And again, I can format that to be a percentage. And here I can change the decimal up here. And as I've been doing with the apostrophes, I like to keep those formulas to the left. Nice to have them for reference. So there's 3 classic probabilities that could be calculated from this, and there are more. And if the length of the table is not that long, you can do these pretty easily. So now, the next question I have is utilizing the expected value. So how many items could I expect to be purchased if there were 30 customers? So total items purchased from 30 customers. And here, I need to left align that cell, which for some reason didn't happen with this one. And I need a little bit room here. So the question is, if I have 30 customers, that's 30, and I multiply that by my expected value cell in D8, and I hit enter, I can expect that 30 customers would purchase almost 43 items. And that's helpful to know if I can get preliminary information on customer traffic that day. I could say, all right, well, if there were 30 customers in the store that day, I should see about 43 items sold. If it's more than that, I might want to find out why we sold more than that. And if it's less than that, I might want to find out why as well. So here we're using the expected value, weighted average, calculation of 1.43 above, in a practical sense to help estimate sales for a certain day or condition. I hope you found this helpful. Thank you.